Factors, such as the lack of chromophore, as well as the extreme pH that's required for maintaining stability, often make choosing a technique for carbohydrate analysis difficult. Common liquid chromatographic (LC) methods often combine metal flow paths with corrosive mobile phases, and less sensitive detection methods such as refractive index (RI) or low wavelength ultraviolet (UV). This makes the analysis less robust and hard to reproduce. Like LC, gas chromatography (GC) also provides challenges where derivatization is needed. Finally, common silica-based amino-bonded columns are difficult to reproduce using typical LC and GC methods. These drawbacks make this method of carbohydrate analysis time-consuming, labor-intensive, and unnecessarily costly. There is a faster, easier way to improve the reproducibility and accuracy of your results, while also boosting speed and productivity. An automated solution with minimal sample preparation and no derivatization, using just add water technology to electrolytically generate the eluent at the concentration required when you need it. With the Thermo Scientific Dionex ICS 6000 new dual eluent generation (EG) workflow with high-performance anion exchange chromatography (HPAE) and Thermo Scientific Dionex CarboPac 1 mm format columns, you can directly quantify even trace levels of simple to complex carbohydrates with minimal sample prep and no derivatization. It is also the only solution that offers a dual eluent generation cartridge (EGC) mode workflow to cover everything from simple monosaccharides to complex carbohydrates, with a fully inert peak flow path and columns to match. With dual EG, even oligo and polysaccharides can be detected with EG, and there are no mixing delays as the eluent is generated electrolytically as programmed by the software. The Thermo Scientific HPAE chromatography takes advantage of the weakly acidic nature of carbohydrates to give highly selective separations at high pH, using a strong anion exchange stationary phase. Coupled with pulsed amperimetric detection (PAD), it permits direct quantification of non-derivatized carbohydrates at low picomole levels with minimal sample preparation and cleanup. HPAE-PAD is extremely selective and specific for carbohydrates because pulsed amperometry detects only those compounds that contain functional groups that are oxidizable at the detection voltage employed. Sensitivity for carbohydrates in orders of magnitude greater than for other classes of analytes. Neutral or cationic sample components in the matrix elute in or close to the void volume of the column. That means that even if such species are oxidizable, they don't usually interfere with the analysis of carbohydrate components of interest. This means that HPAE-PAD is specific and sensitive for the analysis of carbohydrates, from monosaccharides to polysaccharides with the range of CarboPac columns. Simplify the complexity of carbohydrate analysis with the Thermo Scientific Dionex ICS 6000 new dual EG workflow with HPAE. Contact your Thermo Scientific account manager for a quote today, or download the product specification SP72566 at thermofisher.com/complexcarbs.